Hello everyone. In this video, we're going to talk about computer architecture and organization. Computer architecture and computer organization. So, what is computer architecture? Computer architecture here has been defined to say computer architecture refers to the design of a computer system, including the components and their interconnections. Uh, the instruction set architecture, which is the ISA, and the system's performance characteristics. So, computer architecture, apart from that, it can also be defined as the blueprint for how a computer system is structured and how it operates. So, if you look at this statement here, it has a few key components I would like us to look into, which is uh, design of hardware components and their interconnections, their instruction set architecture, and the system's performance characteristics. So if you look at the hardware design, the design of the hardware, this is simply how components like the CPU, the memory, the output and input devices are arranged, and how they interact together to form one computer system. Then, talking of instruction set architecture, which is the ISA, we might ask ourselves to say, what is the ISA? So the ISA is simply a set of commands or instructions that a computer understands and executes. Think of it as a native language for computers. Uh, an example I can give to say English. English is a native language in England. Uh, Bemba is a native language in the northern parts of Zambia. Think of it that way. And then this language we're talking about here, which computers understand, is the hardware language, which is the machine code and the binary instructions, which are the ones and the zeros, so on and so forth. Looking at the last point here, which says systems performance characteristics, what are they simply trying to tell us here? So this simply means it's trying to define how efficient and quickly the system performs tasks, measured by things like speed and energy usage. That's what is meant by the system's performance characteristics. Moving on to the next point here, which says computer architecture focuses on high-level design systems such as overall organization of a processor, the memory hierarchy, the input and output systems, the communication channels between these components. So in this point here, they're trying to explain how the entire computer is organized, not just the parts, but how they all work together. If you talk of the processor, which is the CPU, this handles data and instructions. Then talking of the memory hierarchy here, what this simply means, the memory hierarchy is how different types of memory is arranged and accessed from fast to slower RAMs and storage. Talking of the output or input systems, this is simply just the devices, the output and input devices, which are things like the keyboard, monitors, and the hard drives, how they all interact together with the CPU. To make one thing. Then the last statement there says the communication channels between these same components. These components are the processor, the memory, and the output or input system. The communication channels, this simply refers to the pathways that transfer data among these same components. So think of it as a road or a route that data is transferred through to all parts of the computer, or to these components we're talking about here, the components we've highlighted in this point there. Moving on to the next point, and the last point, talking about computer architecture. It says computer architecture deals with the design of instruction sets, which is the interface between the hardware and the software system. So if you look at this point there, it says it's just dealing with how the instruction sets are designed. It's dealing with how the software part of a system and the hardware part, how they interface or how they interact together. So this same design of the instruction, this is simply connecting the software to the hardware part, and it also defines how software tells the hardware what to do. Think of it like it's a translator between code and machine instructions. So it's a translator between codes. Examples of codes I can give is Java codes, Python codes, and many other codes you can think of, and machine instructions, which we earlier talked about to say machine code and binary instructions. That's what this last statement there is simply trying to outline. So we move on further to talk about computer organization. What is computer organization? So computer organization refers to the operational units and their interconnections, and computer organization refers to the operational units and their interconnections that realize the architectural specifications. So trying to understand this point, we would just say computer architecture describes how the internal parts of a computer work together to carry out tasks. I would say computer organization is more about the behind the scenes operations. It just talks about the internal parts, how they all interact together, not the external parts like computer architecture. The next point there says computer organization deals with the low level design of systems. Computer organization deals with the low level design of systems such as logical circuit design of the processor, the memory organization, the peripheral devices, and the data path of the computer. So looking at these points I've highlighted, it says computer organization deals with a low level design of a system, such as the points I have highlighted here. So what is simply meant by logical circuit design of the processor is just the wiring and the decision making system inside the CPU. To keep in mind to say the processor is the CPU we are talking about here. So this logical circuit design of the processor is just talking about the wiring and the decision making systems inside the CPU. It also determines how instructions are handled step by step. This same logical circuit design of the process, it determines how instructions are handled step by step to ensure a correct flow of information. Then the next point there says the memory organization. What is meant by memory organization? So this memory organization just defines how and where the data is stored. It simply defines how and where the data is stored. Think of memories like the RAM or the cache. RAM or the cache. Yeah. So what is meant by the RAM, the cache, sorry, is cache is just another type of memory, but it's very small and fast, and it is found inside or close to a CPU. That's what cache is. Then under the same memory organization, I would like us to allude to say the memory organization also controls how fast the CPU can access information. The same memory organization controls the speed at which the CPU accesses information. The next highlighted point there says peripheral devices. Peripheral devices. What do we mean by peripheral devices? So these peripheral devices are just the external devices. External devices like the keyboards, the mice, the printers, and so on and so forth. This part of computer organization describes their setup and connections to the processor, which matter for the speed and the efficiency. I'd like us to move to the last point, the last highlighted point there, which says the data path of the computer. So what is meant by the data path of the computer is this is simply the routes or the pathways data travels within a system. Remember we said computer organization describes how internal parts of the computer work together to carry out tasks. So this part there which says computer path or data path of the computer, this is simply the pathways data travels within the system. Think of it data traveling from the CPU to the memory, then from the memory to the input or the output devices and back again. So that same pathway it takes from the CPU to the memory to the input and output devices. That's what is being explained here by this point which says the data path of your computer. Then just to add on, the data path is essentially the physical and logical route that instructions follow inside the CPU to be executed. That's what the data path is, as by definition. That's how we can define what a data path is. We move on to our last point under computer organization, which says computer organization also deals with the implementation of instruction set architecture, the ISA, which includes design of the instruction decoder, the control units, and the execution units. So computer organization, just to repeat this point, it's trying to tell us how or the means of taking the abstract list of instructions to the CPU for it to understand and build real working hardware that can execute them. That's what this point is trying to outline there. The key components in this statements are the highlighted sentences, which are implementation of the ISA, the design of the instruction decoder, the control unit, and the execution units. So think of these things as they work together. They work together to make one thing. Then just to define what each and every part I've outlined here, what it simply means, or how I can split it for easier understanding. The instruction decoder translates the instructions into signals that the CPU understands. So this part gets the instructions, the instructions that were given to it, like I earlier said, in computer organization. This instruction decoder translates these same instructions it receives into signals that the CPU will understand. In short, it just interprets the blueprint. So the decoder interprets the architecture. In short, it just interprets the blueprints and turns the signals to a language that the CPU is going to understand. Then, talking of the control unit, the control unit directs the flow of data. Like think of it like a conductor coordinating what each part of a computer does. So the control unit there, it directs how data flows, and it also coordinates what each part of the computer does. It's more like it organizes every part of the computer. Then the last point there, which says execution units. This is where the actual work now happens. The actual work happens there, which are the arithmetics, maybe also accessing the memory and so on and so forth. Then we can simply say this execution unit does most of the heavy lifting. So to break them down, just to simplify them into simple and straightforward statements, we'll say the instruction decoder interprets the blueprints, the control unit organizes the workers or the parts of the computer. That's what we are referring to as workers there. Then the execution units does the heavy lifting now. That's where the work now happens. Then keep in mind to say all this interpretation of the blueprints, organization of the computer parts, and the heavy lifting, it all happens in nanoseconds. So this process there is very, very fast. So we'll end there for computer architecture and computer organization. Stick around for the next video, because we're going to be talking about examples of computer architecture or computer organization. And then we're going to also talk about components and functions of a computer in the next video.